Okay, so now we're going to talk about the difference of squares. Let's say that we have a binomial like 2x plus 3 times a binomial 2x minus 3. Okay, so notice that the two binomials, they look very similar, right? Like the only difference is one has a plus and the other has a minus. Now, if we were to FOIL it out, 2x times 2x, that would give us 4x squared. 2x times minus 3 would be a negative 6x. And then 3 times 2x, that would be a positive 6x. And then 3 times minus 3 would be minus 9. But then look what happens when we combine the O and the I. They drop out, right? So you get 4x squared minus 9. This is called the difference, because it's subtraction of 2. Sometimes they say of 2 squares, sometimes they just say of squares. Okay, and what we mean by that is this is a perfect square. 4x squared is a perfect square. 9 is a perfect square. And you're subtracting. So it's called the difference of squares. All right, now here's the formula then. If you have a plus b times a minus b, and by the way, it could be, the one with subtraction could be first, the two binomials could be in the other order. But it's going to multiply just to be a squared minus b squared. So you don't even have to do the O and the I. They're going to drop out. You just do the a times a and the b times minus b. Okay? So that's the advantage. Now, we kind of saw this the other day with another video. Remember when we were talked about a conjugate? And I think we had like 1 plus the square root of 5 times 1 minus the square root of 5. I think that's what we had. And we just had the 1 times 1, and then we had the minus square root 5 and the positive square root 5. And we said, oh, those drop out, those make 0. And then we had minus the square root of 25. And it all wound up being like minus 4 or whatever. But 1 minus 5, which was minus 4. That was the problem I remember from the other video. But this is very powerful, the difference of squares. And one of the ways we can use it is with a conjugate. Okay? All right, but right now we're not doing conjugates. We're just doing polynomials that we're working with. So anyway, that is a little reminder there. Okay, so multiplying binomials resulting in difference of squares. So we're going to multiply 9x plus 4 times 9x minus 4. You don't have to do the O and the I. You can just say 9x times 9x is 81x squared. And then 4 times minus 4, it's going to be minus because it's a difference, right? Difference of squares. And then that's going to be 16. Now, you could still do it with FOIL. Like if you're just not sure or you don't remember, you could still FOIL it out and it'll all work out. Okay, but difference of squares is very powerful, and we use it for things. You want to see another example? I'm assuming you're saying yes. Okay, so let's say you had 3x plus 1 times 3x minus 1. Then you just go 9x squared minus 1. See, I like these ones. One more example, just because I wanted to show you one other thing. So let's say you have 5x minus 4 times 5x plus 4. It's still the difference of squares, even though the minus one's first. You're just going to go 25x squared minus 16. Okay, well, I could keep making these up, but I won't. All right, difference of squares.